And welcome to this final chapter of the book. Here in this section, we'll be looking at exponential functions and logarithms. Now, we will explore exponential functions, drawing graphs and plotting graphs of exponential functions. We learn how to differentiate them, and you will use exponential modeling. Then what you realize is that logarithms are actually the opposite side of the coin to exponentials. So exponentials and logarithms are opposite sides of the same coin, just like integrations is the opposite of differentiation. So we learn some rules about logarithm laws, and then how to apply it to solve certain equations and simplify nonlinear equations into linearized equations. And then this will be applied to some nonlinear data, which is also used in A2 level uh, applied mathematics section as well. So learning 4G will definitely help you with the very first chapter of applied mathematics in year 13. So let's get to it. As always, just before we get to the prior knowledge test questions, here are two examples of exponential models. Here we've got an exponential decay, where it happens for nuclear in nuclear physics. If you study some physics, you should be familiar with half-lives of certain uh, decaying material. Now, those material, we're not going to go anywhere near those, but that's applied example of those exponential model. This is a negative exponential curve because it's going downwards. It has a downward sloping. And here is an upward sloping curve, and it's growth of a bacterial population where it seems like exploding, but it will crash at some point because no population will rise indefinitely. There's always some sort of resource factor that will make it crash at some point. All right, so here are the prior knowledge test questions. Simple, just simply have a go at them, and then I'll show you the answers. So pause the video, have a go. All right, I hope you have had a go at these questions. Question one is simply just substitution. All you have to do is substitute these values into the expression and tell me what the answer is. So, pardon me, 5 to the power 3 is 125, 3 to the power of minus 1 is 1/3, and so on. You substitute 3 in here, and 6 minus 1 is a 5, so 2 to the power of 5 is 32, and so on and so forth. Minus 1 makes it 7 to the power of 2, 11 3 plus negative 3 makes it 1, because 11 to the power of 0 is 1. Now, simplifying those expressions with index laws will give you these answers. And finally, for plotting the graph here is difficult, and I've made the graph for you here. It should look something like so, where the values don't lie exactly on a line, but they're fairly close to a straight line. And the gradient and the intercept of the line will tell you, as you remember from chapter 5, all you have to do is take any 2 points on this table and just calculate the gradient and calculate the intercept with this equation. If you don't remember, after you found the gradient, you substitute it into this formula, and the intercept will have been calculated for you if you rearrange this equation. Okay, so m just simply changing y divided by changing x between any of those two coordinates. So there you go. All right, so I will see you in the next section, where we'll start looking at the exponential models. Exponential.